Now, before sizing a solar power system, you need to take into consideration the power rating of your loads and the runtime hours of the loads. Here we have our daily household appliances. This is a standing fan, a television, this is a blender, decoder, and we have our light bulbs. Now, when using bulbs in the solar system, don't use the incandescent bulb because of their high energy consumption. These are LED bulbs and they are energy efficient bulbs. So their energy consumption is low as compared to the incandescent bulb. So like I said, you need to look at the power rating of each of these appliances, their individual power rating. For this standing fan, the power rating is 72 watts. For this television, the power rating is 133 watts. For the blender, the power rating is 350 watts. The decoder, the power rating is 18 watts. So when you compute the wattage, it will help you in sizing the inverter. Then the runtime hours, for example, the standing fan is 72 watts. So if I want to know the daily energy consumption of this standing fan, I will multiply it by the number of hours I will be using this fan daily. So let's assume I'm using it for 5 hours. It will be 72 multiplied by 5. So whatever I have is the total daily energy consumption of this standing fan. So always do well to carry out a load audit to know your energy consumption. So to know the energy consumption, multiply your power rating by the runtime hours. And there are different ways for you to know the energy consumption of your appliances or the wattage of your appliances. If you want to know the wattage of your appliance, that is the power consumption, you look at the back of the appliance like this one. There's a small label, or you call it the specification sheet or the nameplate. The nameplate will tell you the power rating of the appliance. It is always written at the back of the appliance. Like this television, the power rating is written behind this television. There's a nameplate here. Now, at times, the wattage may not be written there. What you see is voltage and amps. Power is voltage multiplied by current. So if you have the voltage, the AC voltage, and the AC current of this appliance, because these are all AC appliances, so you multiply the current by the voltage. But there are some that they have what's called an adapter. That adapter has already converted, it's a converter that's already converted the AC to DC. Like this decoder, it is using an adapter. So you plug the adapter to your AC outlet, it will now convert that AC to DC, step down the voltage. So what you'll be having, the input here is DC 12 volts, and the DC current is 1.5 amps. So here you multiply the DC voltage by the DC current. It will not give you the power rating of this decoder, because 12 multiplied by 1.5 will give you 18 watts. So always do well to know the power rating of your appliance, then to know the total daily energy consumption of that appliance, multiplying by the number of hours you are using that appliance per day. So I'm going to show you how to size a solar power system that will power these household appliances. Please let me know where you're watching from in the comment section. So here is our load analysis table. We have the TV, decoder, standing fan, blender, inner lights, security lights. So the TV, we have 1, and wattage, the power rating of the TV is 133 watts. The total power will be 133 multiplied by 1. It will give us 133 watts. Assuming we have 2 television or 3, it will be 133 multiplied by 2 or 133 multiplied by 3. So the runtime is 5 hours. It means we are using this TV for 5 hours every day. Then the total daily energy consumption of this TV will be 5 hours multiplied by the total power, which is 133 multiplied by 5. It will give us 665 watts hour. So you do the same thing for all other appliances. The decoder is 118 watts, and the total energy consumption is 90 watt hour. So This is how to prepare the load analysis table. And from here, you have two data you're going to use: the total power and the total daily energy consumption. The total power here is 648 watts, and the total daily energy consumption is 2,271 watts hour. Now, this total power is what you use to size the inverter. The inverter we are going to use to power all these loads. Then this is what we are going to use to size the battery bank, our battery bank, and the solar panels. We will use this total daily energy consumption to size the battery bank and the number of solar panels that will generate the energy that will be stored in the battery bank. So the next components we are going to size, or the first component we are going to size, is the battery bank. So I'm going to show you how to size your battery bank. Now, this is how to size the battery bank. We have 7 steps. The first step is to determine your total daily energy consumption, which we have from our load analysis table after carrying out the load audit. So our total daily energy consumption is 2,275 watts hour. Then step 2, divide step 1 by 0.9. 0.9 here is the inverter efficiency. Check my previous videos. I explain what the inverter efficiency is. So if you divide by 0.9, you have 2,271 divided by 0.9. This will now give us 2,523 watt hour. Step 3, add any consumption from DC loads. Now, if you have DC loads that you want to connect to the solar system, you know the DC load, you will not connect it directly to your inverter. There are DC loads that you connect either to the charge controller or directly to your battery bank. So you don't need to divide by the inverter efficiency because you are not connecting them to the inverter. So for this one, we don't have any DC loads. So our total daily energy consumption will still be 2,523 watts. But if we have energy consumption from DC loads, we add it to this one to give us the total daily energy consumption. Now, step 4, you multiply step 3 by days of autonomy. The days of autonomy are days you want the system to power your loads even when there is no sunshine, there's no charging from the grid, charging from solar panels. So our days of autonomy here is 1. We are having 2,523 watt hour multiplied by 1. If you want to choose 2 days of autonomy, you multiply by 2. If you want to choose 3 days of autonomy, you multiply by 3. Days of autonomy normally ranges from 1 to 3 days of autonomy. So any days of autonomy you want to choose, you multiply this step 3 by the number of days of autonomy you want to use. But always discuss this with your clients, the days of autonomy, because when you increase the days of autonomy, the size of the system will increase. If we multiply this value by 2, this one, the total daily energy consumption will increase. And by this, it means the size of the battery bank will increase, and this will also increase the cost of the system. So discuss it with your client to know if he will be comfortable with it, because you have to work according to his budget. Then step 5, we have divide step 4 by temperature compensation factor of 0.9, which is equal to 2,523 divided by 0.9, which will give us 2,803 watt hour. Remember, when you're charging the battery and discharging the battery, there's always increase and decrease in temperature. So temperature also affects the age or the performance of a battery, so you have to take it into consideration. So we have a temperature compensation factor of 0.9. Then step 6, divide step 5 by DOD. DOD here is depth of discharge. So we are using 0.6 as our depth of discharge. This will be 2,803 watt hour divide 0.6. So we now have 4,672 watt hour. The last step is we are dividing step 6 by the nominal system voltage. Step 6 here is 4,672 watt hour. That is what we're having. And the nominal system voltage, that is the DC input voltage of your inverter. Are you going to use a 12 volt inverter, 24 volt inverter, or 48 volt inverter, or 36 volt inverter? In this case, we are using 24 volts inverter. So if you divide 4,672 watt hour, divide 24, we will have 194 amps hour. It has changed to amps hour, the capacity of the battery. Then approximately this will give us 200 amps hour. And this, you can have something like this. This is two batteries, positive, negative, positive, negative. This is 200 Ah, 200 Ah. Since it is 24 volts, you connect them in series. So this is be your positive and your negative. So this is what you will send to the inverter, and also connect your charge controller to this battery bank. So the two batteries are connected in series. Why? Because it is a 24 volt system. Now, if it is a 12 volt system, we can connect these two batteries in parallel. We will not connect them in in series, because this is 12 volts. This is also 12 volts. So we can connect, reconfigure the system to a 12 volt system by connecting these batteries in parallel. Now, when you connect in parallel, the voltage will still remain 12 volts. It therefore means you are going to use a 12 volt inverter. So if we connect these batteries in parallel, like this one now is 24 volts, 200 amps hour. Now, if we connect them in parallel, the system will change. It will now be 12 volts and 400 amps hour. So you can use a 12 volt inverter or a 24 volt inverter, but the configuration, the battery bank connection will change. If you are using 24 volt inverter, you connect the two batteries in series to give you 24 volt, 200 amps hour. If you are using a 12 volt inverter, you connect in parallel to have 12 volts, 400 amps hour. So since we are using a 24 volt inverter, our battery bank is 24 volts, 200 amps hour. So this is how to size your battery bank. The next one, I'm going to show you how to size the solar panels that will generate the energy that will be stored in this battery bank. All right, this is how to size the solar panels. Please don't forget to let me know where you're watching from in the comment section. Now, the total daily energy consumption from step 3 in sizing the battery bank, when you go to step 3, when we are sizing the battery bank, is 2,523 watt hour. After, dividing by the inverter efficiency and adding all the DC loads, if you have any, it is 2,523 watt hour. The next step is that we are dividing this value by the performance ratio of the solar panels, and we are using 0.65. Watch my previous videos. I explain how the meaning of performance ratio. Now, we have 0.65. 2,523 divided by 0.65 will give us 3,882 watt hour after dividing step 1 by the performance ratio of the solar panels. Ideally, solar panels don't perform 100% of their rated capacity. So we need to put a safety factor so that our solar system will perform efficiently. Now, step 3, we divide step 2 by peak sun hours. Here we are using 4 hours, the number of sun hours on the average that you have in your location. So we are using 4 hours. So 3,882 divided by 4 hours will give us 971 watts. The last step is that we are dividing step 3 by power rating of the solar panel. So we are using 350 watts. You can use 200 watts, 150 watts, 440 watts, 500 watts, or 550 watts. But here we are using 350 watts. So if we divide 971 by 350, we'll have 2.8, approximately 3 pieces of 350 watt, solar panels. So this is how to size, your solar panels. So you can connect these solar panels in parallel if you are using a PWM solar charge controller. You connect them in parallel. Now, if you are using an MPPT charge controller, you can connect the 3 panels in series because the MPPT charge controller have a higher PV input voltage, but the PWM charge controller, the PV input voltage is always low. So you try as much as possible to connect the solar panels to match with the nominal system voltage of your battery bank. So here we are using 24 volts. So these 350 watt solar panels, if we connect them in parallel, they will still be able to charge the 24 volts battery bank if we are using a PWM charge controller. But for the MPPT charge controller, you can wire the 3 solar panels in series. So the next one is how to size the solar charge controller. Don't forget to let me know where you're watching from. Now, to size the solar charge controller, size of SCC, which is solar charge controller, is equal to maximum power of the solar panels divided by maximum power voltage. The maximum power of the solar panel is 1050 watts. There are 3 pieces of 350 watt solar panels multiplied by 3 will give us 1050 watts. Now divided by the maximum power voltage of the solar panel we have choose. The maximum power voltage of the 350 watts I have choose to use in this calculation is 38.48 volts. So if you divide by this, you have 27.3. Now you multiply this by 1.2. 1.2 here is a safety factor. So if you multiply 27.3 by 1.2, it will give you 32 amps. But it is difficult for you to get the 32 amps charge controller. So you use 40 amps or 45 amps solar charge controller. So, but if you have a 40 amp charge controller, make sure the maximum PV input power is can handle up to 1050 watts. And if you're also using 45 amps, you should make sure it can handle 1050 watts. Now you can wire the panels in series or in parallel depending on the charge controller, whether it is PWM or MPPT charge controller. The size of the inverter is total power of loads divided by 0.8. From our load analysis table, the total power rating there of the loads is 648 watts divided by 0.8. Safety factor is equal to 810 watts. Yeah, this is approximately, you can use a 1 kVA inverter, but it's difficult for you to get a 24 volts 1 kVA in inverter. So you can use 24 volts 1.5 kVA. But if you are using a 12 volts inverter, you can get an inverter that is rated 12 volts 1 kVA. If you want to reconfigure the system to make it a 12 volt system. Now, but if you are using it for the 24 volt system from our battery bank, we are going to use 24 volts 1.5 kVA inverter. Why? It is difficult to get an inverter that is rated 24 volts 1 kVA. But if you have the inverter, it will still work very well here because the size of inverter that will power this load is 810 watts. So this is how to size a solar power system for your home. Do well to let me know where you're watching from, and also let me know the power rating of your appliances. If you know, you can just drop it there in the comment section. If you need my PDF on how to size a solar power system, the step-by-step you need to size a solar power system, click the link in the description of this video to download the PDF. It is not free. You pay a little amount to support and encourage my work. Thank you for watching. See you in my next video.